What we're noticing in looking for equivalent expressions is that the original expression, x plus x plus x plus x plus x, gives us a total of 5x, or 5 groups of x. In this case, the number 5 is the coefficient for the variable x. Remember, the coefficient is a number that comes in front of a variable to tell you how many groups that variable you have. So we're going to look for any expressions that give us a total of 5 groups of x. If I go down to expression A, I can see that 3x plus 2x would give me 5x. So this is a correct equivalent expression. For expression B, similarly, it already shows 5 groups of x. I have the coefficient 5. So this is also a correct expression. If I come down to expression C, x to the power of 5, I know, using my knowledge of variables, that that is actually equal to x times x. I'm going to do these in parentheses instead. X times x times x times x times x, because an exponent tells me how many times to multiply the base by itself. This is not 5 groups of x. This is x multiplied by itself 5 times, which would be very different. So this is not equivalent. If I come down to expression D, 7x minus 2x, 7 groups of x minus 2 groups of x would give me 5x. So this is an equivalent expression. And then expression E is a little bit tricky. We might be tempted to see that we have 4x and then another group of x, and we might think that that means 5 groups of x. However, because I have my 2 groups in parentheses and there's no operation, that means that I'm multiplying the x times 4x. So this would give us an exponent. What I would end up with is 4x 4x squared. And this is incorrect. That does not give me 5 groups of x. So when we're noticing equivalent expressions, we want to make sure that we're finding the total groups of the variable and that the coefficient matches once we simplify both expressions.